Today I'll be talking about computer network and its basics. Yeah! Well, computer network is basically a network that is probably the most familiar with us this day. Everyone has a computer in their house, right? Well, computer network is basically a network or link that is connected between computers, like this, in order to transfer information from one computer to another very quickly. So example, information from this computer can go to this computer very quickly through this network. LAN or local area network is one of the three types of networks that are most commonly used currently. LAN is the smallest type of network out of all three types. It is a computer network that is used only in a house or a building. It does not include multiple buildings, so it can be only inside your house, not the other parts of the city. MAN or Metropolitan Area Network is the one that covers commonly an entire city. It links between multiple buildings or houses, and it only has the range of under 30 miles. It cannot go over 30 miles. It covers the entire city. WAN or Wide Area Network is the biggest type of network we have currently. It usually has the range of over 30 miles. It connects multiple cities and areas, even a country itself. And internet is the biggest WAN we have ever yet. So these are the three basic types of network we have currently. Node is any kind of device linked or contained in a computer network. It can be a computer or printer, for example, which are the most common. So they're all linked to each other, and a computer is a node itself. Printer can be a node itself too. All nodes are connected to each other through devices called communications media. Communications media is a tool used to connect each node basically. The two most commonly used communications media are cables and fiber optic cables. Cable is the more commonly used one, and people use them in their work or houses for basic functions. And then it is more simple and common compared to the fiber optic. It is usually single-stranded and connects to the different nodes. And the fiber optic cable is the more advanced one and the rarer one. It is used to connect fiber optic network, which is more complicated, and then it's way more advanced and functional compared to the cable. That's basically about the communication media and the link with nodes.
Alright, so there are a lot of words that you need to know in order to talk about networking. So one of the words that you really need to know is called workstations. And workstations are basically personal home computers like the one you see right here. Another couple words that you need to know are clients and hosts. And so clients are any part of the network that receives the data. And then hosts are any part of the network that gives out the data, or it's a place where the client gets the data, or places like news or Facebook and stuff like that. And so now if you see here, let's say that computer is the client and this computer is the host. And so the client over here will go over to the host like this in order to receive information. And so the host then recognizes it and then gives the client information back. That is how clients and hosts work. Now, another concept that you really need to know is called servers. And now servers are it offers different users to access the same information. So for example, a website can be an example of something that would be a server. And so if you see here, that is an example of a server. And these are computers that access the same information. Now let's say all these computers want to go to the same website, like Facebook. So this computer right here would access into this one, and then the second computer would also do the same, and same for the third computer as well. So that's how servers work. Now third, there is the NIC card, or the network interface card. And what it does is it's basically connects you to internet. So that is an example of a NIC card. And there are a few commonly used NIC cards. First of all, there's the Ethernet card, which you see right there. It basically connects you to a cable modem. And then there's the telephone NIC card, which connects you to a telephone line, which you just saw right there. And then lastly, there's the wireless card. It's a special card that you don't need any lines or cables. It directly connects you to the internet. So all these NIC cards that you just saw allow you to connect to a network.
So today I'm going to be explaining topologies, and what a topology basically is a network's shape and structure. So it's how the data gets moved from place to place, like a computer to computer or node to node. And the 5 basic topologies are bus, ring, star, tree, and mesh. So first, the bus topology, there's basically a terminator on each side, which is basically when the data goes here, it's destroyed. So there isn't any excess data here that's causing noise or anything. So the data is connected. Well, it's connected like that, and then there's a computer. It's connected to this. There's a server connected. There's also another computer. And how the data moves from this computer to this computer is the data moves from this computer to this, then it moves along, it goes to the server, and then it goes along again to this computer, and then it finally goes to the terminator where the data is destroyed. This way the data won't leave any excess data here, which will cause overload on the server. The next topology is a ring topology, and not like the bus topology where the data is eventually destroyed. Here the data continually moves around the ring, and there's a couple of computers connected. And if this computer wants to send data to, let's say, this computer, then it sends data through this, and then it goes around the ring, and then it goes here to this computer where the data is saved here, and then it moves along to the other computer where the data is finally reached at its destination. So unlike the bus topology, there's no data destroyed, but rather it keeps moving around the ring.
Star topology is one of the oldest topology used. What happens here, there is a device called the switch, and it's connected to all these computers outside of it. Since all the computers are connected, if one computer, such as this computer, wants to send information to maybe this computer, what will happen will, the information will travel into the switch and then back out of the switch to that computer. That's really simple, isn't it? That's it. The next topology is called the mesh topology. Get it? Mesh topology. It's all the topologies pretty much combined together. Mesh topology. So this is when all the computers are connected to each other without a device. So let's connect the computers, like maybe this, that, that, that. So that's not the only way it's connected. It's actually connected with each computer, just simply like this. So, if one computer wants to send information to another, like this one, it actually can send information through maybe like that, through this computer into that computer. But let's say this computer broke down and you need to send information fast. Well, we can't send it through these ways either, because now, since that computer is broken, it's not going to work with this computer, is it? Oops. Oopsie. So if that computer is broken, these ways are broken too. And we can't fix the computer fast enough because we need to send this data fast. Then what we can do is we can have this send to that way. Mesh topology is like a backup plan, I guess. It's actually really popular in big cities, not really small cities.
Alright, so I know you guys have learned a little bit about networking, but networking wasn't always this easy in the past. In the past, if you wanted to share information between computers made by different companies, it didn't really work. For example, if you wanted to share information between a computer made by IBM and a computer made by Macintosh, it didn't work. And that was a big problem, and so the OSI model was created. And OSI stands for Open Systems Interconnection, but everybody just calls it OSI. And basically this is made to standardize networking and to ensure that different companies could share information. And here I made it into a little pyramid, and as you can see it has 7 layers. And the layers go up starting from here, like 1, 2, and so on. Well, if you look at the bottom layers, these layers are mainly for transmitting data. These two, the physical and data link layers. And if you look at the middle 3 layers, these layers were mainly made to communicate between different computers. For example, if I wanted to send something to your computer from my computer, that's what those layers are for. And if you look at the top 2 layers, these are the kind of presentation layers, and these are what your software programs are, and then these present the data to you. And if you look at the physical layer, the physical layer it's made up of like the actual physical things that you can see, like cables and fiber optics and radio waves and network connectors and all that other kind of stuff. So if there's a problem with your computer and the person says it's a problem with the physical layer, that means something like that has a problem. And if you know anything about computers, about binary numbers, well, you know that data is transferred using binary codes, and binary codes are made up of zeros and ones. Well, so that's great, but how do you send information between computers? Like, how do you send all those zeros and ones? Well, basically, there's 2 ways to send information between computers, analog and digital.
There are 2 types of signals that you can use to send a set of data to another computer, such as this iMac right here. And the 2 types of signals are called the analog signal, and I'll just write an A for that, or a digital signal, and write a D for that. I'll talk about the analog signal first, and I'll draw a line. And this will represent 0 voltage. And for analog signals, the waves can vary, and these are the signals, and they're going waves, and just like I said, these waves vary. So I'll draw a wave. Say it goes like this. And the line here it's a positive volt, so then it will signify a 1. Also, it should reach like this. So ignore this part. So pretend it all reaches this line here, and it will equal a 1. And just like that, on the bottom, there's a line here. Again, it should reach this line, and it's negative volt, so it will equal a 0. So this will send a binary signal, and this is pretty long, but 1 0 1 0 1 0, and then so on. And to your computer, these will actually signify something. Next thing I'll be talking about is the digital signal. The digital signals were actually introduced later than the analog signal, and they thought it was better than sending signals over, for example, a radio. And this can be especially found in LAN and local networks, among others. So, again, I'll draw a line. So the main difference between the analog signal and digital signal is that instead of waves that vary, you have a specific voltage. And I'll show you that. So this will say equal 5, and this here will equal, and again this is also 0 voltage, and then this can equal 5, and or it doesn't have to be 5. It's the good point about digital signals is that it's a specific voltage, so this could be a 7 also. And also you can have positive or negative numbers. So then I'll use this part here, and so just like I had 7 or 5 or whatever number, I can have a negative number. So if this is 0, and then I can have a negative 7, for example. Next thing I will talk about is a fiber optic. The fiber optic is actually a digital signal, and it's the fastest thing so far. And how this works is that if you have a light, it will equal, if this is the light, it will equal 1. If it doesn't have light, it will mean 0. Now we'll be learning about the data link. But looking at this, can you find the data link? Yeah, you're right. It's located right here, and it's above the physical layer. So this is what we'll be learning about. The binary code. For those of you who still might not know, binary code is made up of 2 numbers, specifically 1s and 0s. So it can, for example, look like this, something like this. And what the data link layer does is that it puts it together, and then this, and it will organize them into something called frames. And now we'll be learning about what exactly frames are. Frames. So frames is a very important part of this whole process. And what it does is it does 2 main things. It gets the address. And what kind of address does it get? It gets addresses from, and so where the address is coming from, And by address, I don't mean where your friend lives or anything. It's the address of the computer, and it's called IP address specifically. So basically it gets the addresses from where the information or data it's coming from, and to, so where it's going. And another thing that it does is that it checks errors on data. So it's a very important role as, So what happens after the physical layer? So we learned about the physical layer already, and now we want to know what happens after this. So this is an iMac, one iMac, and this is another iMac. So basically, for a very short review, there is a connection between this, and let's say this is the connection, and what's this called? And this is the physical layer. And what it does is that it takes the binary code, which we just learned about. So let's say this is the binary code. So it groups them together, puts them together. Basically, let's say it puts this together, and then it basically kind of finalizes it and puts a I guess you can call a stamp on it, and which kind of directs it to other computer. It's not going yet. It just puts the address on it and makes it all ready for what's gonna come, which is the send off. And what else it does is that it checks for signals. It checks if there's the same signals. We don't want the same signals, right? And so it basically checks if they send in the same signal, and then, or if not only that, or if they're not sending enough signal, so then from one computer to another. And again, for review, this is where the data link is located.
We will continue with the lesson, and if you look at an analog wave with different waves, you can see the interference. It can be from outside radio station, radio on house, etc. And if you get the interference, then the data link layer tells the interference to go back and send it again. And it gets the address of one computer to another, which is called MAC address and physical address. To see where your address is, open command prompt right here and type in cd \, and it will lead you to a root command, and then type in ip config /, and if you press enter, it will show all of the address. But here I scribbled so that I can't see the address because there might be hackers. Yeah, physical address is where the data link mostly uses, and it should be under local area network connection. So yeah.
In this tutorial, we'll talk about the network layer. First of all, the network layer is above the data link layer. And the job of the network layer is to control the passage of packets. And the packets are just units of data that is formatted to be sent out of the network. Just like this, to the network. Okay, suppose there is a binary code 1100. Okay, and this binary code 1100 is the physical layer. The data link layer is like the envelope. It puts an envelope around the binary code, which is a physical layer. And it not only puts an envelope around it, but it puts the address of the sender and the receiver. Like this. Here's an envelope. And then the job of the network layer, which we are talking about right now, it puts a stamp and it sends it to the fastest route as it can in the network. It goes like this. Okay, the network layer gathers information from different networks and parts of the network, and when it gathers all information, the process of the gathering of the information is called discovery, and that is how it finds the quickest path. Okay, and another thing is, certain layers can only receive data at a certain rate. For example, say you can send a packet at a 100 packets per second rate, but the receiver, okay, here's 100 packets per second, but the receiver can only receive, say, 50 packets per second. What the network layer does when this kind of things happen, it splits the 100 packets per second file and then it divides it up into two 50 seconds. So instead of receiving one big file that it can't handle, it will rather receive two smaller files that the receiver can handle easily. And that is the job of the network layer.
Now we'll talk about the transport layer. The transport layer is after the network layer, and they're both similar, but the transport layer basically helps the network layer, and it has two jobs. First, it finds the fastest route. So let's say there's one computer here and one computer here, and this computer wants to send data to this computer. So there may be many routes. A long one. And transport layer basically goes through all the routes and gives them gives each of the routes a unique identification number value, and it's also called a port number, and it gives the number to each one and then finds the fastest route, so and makes sure the data is sent through the fastest route. Now the next job, transport layer also checks for errors in the data, and it makes sure the data is sent or received in the right order. And network layer also checks for errors, but the difference is transport layer checks for different type of errors. So it checks for errors that network layer doesn't check.